Hello students, I am Dr. Saliha Jamal, Associate Professor from Department of Geography, Aligarh Muslim University, Aligarh. Welcome you all to this lecture series of spatial analysis. So this lecture is in continuation to the previous lecture. In previous lectures, we have discussed what is spatial analysis, what are the different types of spatial analysis. We have just introduced the different types of spatial analysis like queries and reasoning in spatial analysis, measurement in spatial analysis, transformations in spatial analysis, etc. And now we are discussing it one by one. So this is the second type of spatial analysis we are going to discuss here, that is measurement in spatial analysis. So that's why I can say here that this is in continuation to the previous lecture. So today we are going to discuss about what is the measurement in spatial analysis, and then we are going to discuss the different types of measurements, that is distance measurement, area measurement, maybe attribute measurement, geometric measurement, etc. Then we are going to discuss the significance of the measurement in spatial analysis, and we can take the examples of its significance through the buffer analysis, overlay analysis, and network analysis. So starting with what actually measurement in spatial analysis. So overall we can say measurement includes determining the spatial attributes like distance, area, direction, and we can say elevation within a geographic data set, and it plays a very important role in different spatial analysis like mapping and in decision mapping. Simply measurement is what we are going to have some numerical value regarding, maybe in terms of the distance between the 2 points, between the two places, between the two cities. That's why it simply includes, we can say, it determines the spatial attribute with respect to the distance, area, direction, elevation, etc. For instance, we can take the example. Let's say city planning department that it wants a most suitable location for a new park. Then it will need various types, the city department will need various types of GIS data set, like information regarding the what are the different parks that is already existing there, where there are residential areas, is there schools are present nearby or not, the road networking and all. Then to make an informed decision, they can use the various measurement within GIS to in order to assess in order to locate a new path. That's why we can say the measurements are essential for spatial analysis and for decision making processes. Not only, we can take another example. For example, in order to locate certain infrastructure facility, for example hospital, schools, again we need different data sets from the GIS, the informations like the road connectivity, the accessibility of the regions, the residential areas of the region. By having these information, various measurements within the GIS, we can locate, we can have the suitable location for the new hospital or new school, we can say. So it plays a very important role in our day-to-day life. Now coming to the types of measurement. Once understanding what in day-to-day life the meaning of measurement is, simply that is taking the distance from one point to another point, one place to another place, that similar measurement is also here we do in spatial analysis. During the different in this different types of measurement, we can see we have the distance measurement, we have the area measurement, we have the attribute measurement. So distance is frequently encountered notion in everyday experience. we used to see the distance when we are traveling from one place to another place. Distance is what? Simply it is referring to the extent between the two objects. What is the extent between the two spatial entity? Among the various distance measures, like there are lots of different distance measures, but Euclidean distance hold a prominent role for its applicability both in vector as well as grid format. When we are talking about the vector, it means the point, polygon, line data and all, and raster, that is the attribute, the characteristics of that spatial data. So Euclidean distance is what we can say, a distance between the 2 points, the line joining the 2 points in Euclidean space. Euclidean space is a we can say a space in geometry. Mainly it represents to represent the physical entity. So it holds a very prominent place, we can say. Now we can say, however, there are several instances where we find the use of distance to, we generally ascertain the distance from the single point to another point, means finding out the distance from one point to another point. But there are certain situations when we locate the distance from point to all other point, that is conceptualizing as distance surface. So there are two methods of distance measurement. One is point to point, we can say, and another is from point to all other point. That is, for example, proximity of features in the landscape. So this is a distance measurement. Another, we can say, example like calculating the distance between the two cities, that is simply we can say point to point measurement. And while we can say that determining the proximity of any feature of the landscape, that is mainly from a single point to all other point, we can say. So another type of measurement is area measurement. Then area measurement simply refers to estimating the size of the polygon, that is the surface, area surface we are talking about. If we are talking about the polygons, we mean that is the area surface. So estimating the size of the polygons, or simply you can say any region on the earth surface. So area measurement, we are going to measure the area of any region on the earth surface. For example, we can say calculating the area of a several forest patch, evaluating the area of just having region occupying the wheat crops, or we can say measuring the extent of land parcel for the urban planning. Just here we are what calculating, we are evaluating the area for certain specific purposes. Now next we can have the attribute measurement. Attribute means simply quantifying the non-spatial characteristic. Suppose spatial characteristic is a particular region, any place, we can say that is a spatial characteristic, and we talk about the characteristics of that place. For example, the population of that place, the income of that place, that it means that is the characteristic, attribute of that place. So there is also attribute measurement, because distance and area measurement, we can say it is sort of vector data measurement. But when it comes to attribute measurement, this is simply we can say quantifying non-spatial characteristics which is related to the geographic features. For example, measuring population density in different region, measuring temperature variations across the landscape, temperature and population density. These are the attributes pertaining to the certain spatial data. So attribute measurement is different from the distance measurement, and we can say the area measurement. Another type of important measurement what we have in GIS is that is geometric measurement. When it comes to the geometric measurement, it has different meanings for different points, lines and surface area. It means we are talking about here vector it means spatial data, point, lines and surface object. When we are talking about the point object, we can say zero dimension, but still the coordinates are there. Point objects, 0 dimension. When we are talking about the linear objects, means linear length, curvature, direction. For example, these are the linear objects. You can take roads, rivers, etc. So when we are taking the surface feature is simply the area. We are talking about the polygon here. Surface feature means polygon. Linear feature means line. We can say the surface features having the 2D characteristics, area, circumference, shape, etc. Again, we are coming to the body features. Body features is the 3D, three dimension, having the volume and the surface area both. So we can say in GIS software we have the functions of geometric measurements also pertaining to the point, line and area objects, either for the vector data structure or for the spatial data of raster data structure. Means both the measurements can be taken through the geometric measurements. Means what the previous measurement we have seen, the distance measurement, area measurement and attribute measurement, all things can be taken in the geometric measurement, the facility that the GIS software has. Now, one by one, we can take the example of these geometric measurements, like calculation of the polygon feature. We can say here, this is the toolbox you can see showing the calculating the geometry of a polygon feature. That is polygon feature. It is one of the most basic parameter of surface feature when we are talking about the polygon feature. Then and this comes under the vector structure, and the surface objects are represented mainly by the polygons formed by the arcs. For example, in this toolbox you have to put area because we are calculating area of polygon feature which is under the vector structure. So here in property we have to give input, that is the area. Then we all know under the coordinate system we generally use WGS 1984 UTM zone. We use this particular data frame, this particular coordinates, and in which units you want area, you can either you want area in square kilometer, square meter, square centimeter, whatever the unit you can you can put here, and after that you can calculate, you can have the area of polygon feature. Similarly, you can have the calculation of line. You can have the calculation of line features. What I have said, line feature is also a type of vector structure, and it is one of the, we can say when we are calculating length is one of the most basic morphological parameters of linear objects. Means topological features of a linear objects. Linear objects may be the roads, may be the rivers, and I have already said that it is also a vector data structure, and it is expressed in sequence of coordinates, maybe in xy or xyz of points without considering the scale. For example, if we want to calculate the line length, then again come to the calculate geometry toolbox. Here you can see the property, in that we have given the previous one when we have to calculate area, we have given area. Now here you have to put length. You have to give the input length with same coordinate system and data frame in which units you want the length to be calculated, whether you want in kilometers, whether you want in meters, etc. You can here, and you can get the result. You can calculate the line length. For composite linear objects, the length of each branch curve should be calculated. For example, any linear feature like meandering rivers. So before calculating its total length, we have to calculate the length of each loops, and then we have to aggregate it. That's why we can say composite linear objects, the length of each branch curve should be calculated before the sum of its length can be calculated. Another type area, we have calculated the area, we have calculated the line length. Now we are calculating the centroid measurement. Coming to the centroid measurement, first we will discuss what is centroid. Centroid is the central position of any, we can say, spatial entity, spatial object. For example, if we are taking any triangle, the centroid is the center position of that triangle. That may be find out by the intersecting point of the medians. Now, what is the medians of these triangles? Median line is the simply which divide each side of the triangle into two equal halves. So the point where it will intersect, it will have the centroid measurement. In simply, we can understand centroid is what is, it is a particular location, central location of the particular entity. So centroid is plays a very important role for characterizing the spatial arrangement of geographic entities. For example, if we have to generate a certain contour map depicting the national population distribution, where the population data is either given at county level or the province level, and we have to prepare the contour map depicting the national population, then here it is very much essential that we have to designate a centroid, a point within each county. So the point we are going to designate, that will act as a centroid, and that will be represented by the, each point will be the represented by the numerical value, because this population data is given county wise, or we can say province wise. Subsequently, in next step, the interpolation is conducted in order to compute the national population contour. We can have the interpolation with national population contours. So here we can say centroid plays very important role. Determining centroids typically involves, we can say, typically involves identifying geometric features, we can say, of a polygon. While this calculation is side forward, we can say very straightforward, simple for the shapes like rectangles, and it becomes more intricate and complex for the polygons. So centroid measurements also can be seen, and its significance can be also seen. Now, significance of measurement in spatial analysis. There are various significance of measurement in spatial analysis. To understand these type of to understand different types of measurement is very much crucial for the spatial analysis and GIS professional, because it helps in day-to-day lives, in routine lives, for finding out the shortest distance between the two places, to know the priority place where the priority deliveries for the certain thing is to be done during the emergency, during the disaster and all. So significance of measurement in spatial analysis plays a very important role. Calculating the accurate distance, and we can say measurements, and it is one of the underlying various spatial analysis, which include various resource location, allocation, environmental impact assessment, and land use plan. Similarly, not only vector data structure can be included in the measurement, but instead the attribute measurement can also be included in order to enhance the information from the spatial data. So previously we have, in previous slide we have seen, during the measurement we can have vector data structure also, and even we can have attribute data structure also. So there is lot of significance that can be understood one by one. You can find here spatial, you can find here the spatial analysis technique using measurement. We are going to discuss it with the buffer analysis. What are the buffers? Buffers are simply the zones, the areas that is created around any geographical entity, any object, any feature based on certain distance or attribute or criteria. Suppose if we have to prepare a buffer, it means around any school, any park, that is park and school is the spatial entity, and we need 2 kilometer buffer. That is the criteria is at 2 kilometer distance we have to create a buffer, a zone. For example, we can take another example, creating a buffer around a river to identify areas that is susceptible to the flooding. The width of the buffer represents the potential flood zone. In this example here, you can see the example that road buffer zone between 1000 meter and 2000 meter. The first one, the red line is the major road we can see, and the first buffer you can see that is up to the 2000 meters, and the second buffer you can see it is up to the 2000 meters. So this is the buffer analysis. We can see the buffer analysis. Another example you can see here, this is the land use land cover around a certain wetland. The blue color is depicted, the blue color here is depicted, you can see that is the water body. Red color is we can say the built up surface, green color is the vegetation, yellow color is the agriculture. So simply here I want to induce the understanding about the buffer. So you can see a buffer, a zone is created around the water body with a distance of 2 kilometer. So this is what we can say, this zone we can say this is up to the distance of, you can see here on PPT, this is the zone is created, a buffer is created around this particular water body of 2 kilometer. For what? For in order to assess the land use, land cover changes and different time period. So here the buffer analysis play a very important role. Another important function of measurements you can see in overlay analysis. Overlay analysis, as the word itself suggests, overlay combines multiple spatial data sets in order to derive new information, new data set by analyzing the intersection of the features. Here we usually overlay one upon the other. You can see the real world, the land usages, you can see the roads, the different streets and all, means different data sets here that are overlaid one upon the other in order to have the new information analyzing through the intersections. For example, overlaying the land use and transportation data in order to identify the areas which are suitable for new infrastructure development. For example, we have to develop certain industrial complex. So we are overlaying the land use the data over it, transportation data, that is maybe in terms of the road networks and all, to see to create from the land use data we will get the vacant space. From the road network we can get the accessibility network good accessibility, then we can have proper decision making that which place is suitable for the industrial complex. So we can have the overlay analysis. Again we can say another example, that is the GIS integration. GIS integration, this is another, you can say, the example of the overlay analysis for environmental vulnerability mapping. By taking different decision criterias and number of criterias, you can say that water supply, water quality index, open drains, overcrowding, narrow streets, air pollution, and number of criteria you can say. You can overlay and you can get the environmental vulnerability map here, you can say. Another example of this measurement application, you can say the network analysis. Network analysis. So simply analyzing the connectivity and relationship within the network, often involving measurement of distance, time or cost. Because network analysis, during the network analysis, generally suppose you have to visit certain place, there are three roads. It depends upon you. You used to analyze which route will be the shortest route in means you will take less time to reach that particular place, or you can say which route is the safe route in terms of having good roads also, because you are seeing the comfort. Or even if you are traveling with the public transport, private some transport, you can see also, you can have the understanding about the cost also. So network analysis is mainly the connectivity and relationship within a network. For example, optimizing the delivery routes for logistic company is based on distance, traffic conditions, and delivery priorities. All these things that is based on network analysis. Finally, in a nutshell, conclusively, it can be said that measuring things on the maps helps to understand the world in more easier and better way. And for example, from measuring from simple rulers to high tech now from the GPS, measuring distance and the areas is simply like uncovering the various secrets of the spatial entities. Even though it can be a bit tricky with accuracy and scale, but still measurements in smart ways like drawing circles, stacking maps one upon the other, finding the best route makes a big difference in our life. So whether it's a planning cities, or whether we are talking about the allocation of the resources, delivery of certain products, we can say these measurements are like superpowers for making smart decisions. And as the technology keeps getting more advanced and advanced with time, measuring things on map will keep on making our world even more amazing, easier, and more wonderful. So thank you all for this lecture. Again, we will meet in another type of spatial analysis in next lecture. Till then, till that, have a good day. Thank you, students.